Okay, let's look at the natural domains of functions, right? The reason why it's called the natural domain is that this is a domain that comes from the formula itself. So domain can be determined by whoever defines the function, but this natural domain comes from the formula, right? There are two rules that you need to look at, and the first one, whenever you have a fraction, we have to make sure that the denominator is non-zero, because we cannot divide by zero. So non-zero, right? So we need to make sure that the denominator is always non-zero. And rule number two, if you have a square root or fourth roots or sixth roots, so even roots, then we have to make sure that the expression inside the square root has to be non-negative, right? Zero is okay, but negative number is not okay, so non-negative. All right, so let's try to find the natural domain of each of these functions. All right, so first one, all right, so we see a fraction, so we have to make sure that the denominator, which is x minus 2, so we have to, so rule number 1 tells you that, all right, denominator, in this case x minus 2, right, has to be non-zero. So that means that not equal to 0, right? Then we can isolate x just like we can treat it like equation. We can add 2 to both sides to isolate x. So x is not equal to 2, right? So we can take this as a domain. So this is all real numbers except for 2, right? Or if you want to write it in interval notation, this is another way to write the domain. So domain D is going to be, right, interval notation. So start from negative infinity, right, all the way to 2, right? But we use the parenthesis, so that means that this is going to exclude 2. And then use a union. They combine with start from negative 2, but not including 2, all the way to positive infinity, right? This is another way to write all real numbers except 2, right? So that's that, right? So let's look at the next example. All right, now we see a fraction, and at the same time there's a square root. So we have to look at both of these rules, right? So rule 1, right, first tells you that, all right, so denominator is square root of x plus 5 plus x. So denominator, square root of 5 plus x, right, cannot be equal to 0. Alright, so we can simplify this by square both sides, because we don't like square root. So we square both sides. We have 5 plus x, right, cannot be equal to 0. Alright, and we can just simply subtract 5 to say, alright, x cannot be equal to negative 5. Right? But there's a square root here, so we need to apply rule number 2 as well. So let's look at the rule number 2. Right? So rule number 2 tells you that the expression inside the square root, which is 5 plus x, right? This has to be non-negative, which means that either greater than or equal to 0. Alright, so then we can just simplify by subtracting 5 from both sides of the inequality. You get the x's greater than or equal to -5. All right. So we have to satisfy these two conditions at the same time. So these two guys combined, right? So you can see that one said that the x cannot be equal to -5, and the other one said that x has to be greater than or equal to -5. So x has to be strictly greater than -5, right? So we can write it the domain this way, or if you want to write it in interval notation, right? So it's a strictly inequality starting from -5, so you have a -5, right? Make sure to put the parenthesis so that it's a strict inequality, then all the way to positive infinity, right? So this is the domain of the second function. All right, that's it. So that's how to find the natural domain of a function. All right, that's it. I hope that this was clear.